everyone, welcome to this webinar organised together by Ecopia AI and Airbus. We hope you enjoy the webinar and learn more about how Airbus Premium High-Resolution Imagery and Ecopia's Advanced Neural Network are supporting geospatial applications worldwide. We'll get started in just a moment, but while we're waiting for others to join, I'll just let you know about a few housekeeping items. So everyone is muted during the webinar. If you have a question at any time, please enter it into the questions box in the webinar panel. We're going to save some time at the end for a live Q&A. And of course, this webinar is being recorded and we'll send a link to you after the event. So my name's Joanna Emery and I'm a marketing manager here at Airbus Intelligence. I'm delighted to welcome you here today for our joint webinar with Ecopia on how do we create next generation digital maps on a global scale. So today's webinar is going to be the opportunity to learn more about how we work together to deliver rapid, accurate and scalable feature extraction for industries worldwide. So to present this webinar, I'd like to welcome Nicolas Journas. He's the One Atlas Marketing Project Lead at Airbus Defence and Space Intelligence, and Abigail Koholik, Director of Channel Partners here at Ecopia AI. So what do we have in store for this webinar in terms of the agenda? We're going to begin by introducing the One Atlas platform. So we're going to look at how you access Airbus imagery. We're going to do a focus on our new Pléiades Neo capabilities, and we're going to take a look and a dive into the One Atlas analytics capabilities. We'll follow this up with the high accuracy mapping extraction product presentation. We're going to take a look at some use cases to make it a bit more real, and we'll finish up with how you can access the analytics. And with that, I'd like to hand over to my colleague Nicolas to dive in.
Thank you, Joanna. So we will start this presentation about talking about One Atlas and our One Atlas platform. So One Atlas is really the geospatial platform of Airbus, where we access to Airbus imagery and as well as trusted artificial intelligence, where we can extract really actionable insight or intelligence at scale. So this is what we are going to talk about today with our partner Ecopia AI and Abigail. So if we go to first, what is One Atlas? One Atlas is about data and analytics. So first, it's a point of accessing our imagery, all our archive with living library, and as well getting access to tasking. So for new acquisition. It's valid for multi-resolution. I will talk about what we have today into One Atlas, and in terms of resolution and sensors, which are coming as well to be integrated pretty soon. In One Atlas, we also have global layers like the base map, which is a qualified coverage for around the world, so worldwide coverage. We also have a digital elevation model with WorldM based on our radar capabilities. And finally, we propose analytics capabilities based on object identification, change detection over infrastructures, like roads or houses, for example. And finally, where we're going to focus today on the land use map extraction and all the capabilities we have developed with Ecopia AI. So if we start with the imagery, we are talking about living library, which is an immediate access to a premium selection of imagery. So here we are talking about Pléiades imagery, so 50 centimeter resolution, spot imagery with 1.5 meter resolution, with an access back to 2012. So we are close to 10 years of archive. Full archive is being made available into a living library, where you can have immediate access in streaming, in download. We have distinctive point of accessing One Atlas, so it can be through the interface. You can connect to your GIS tool S3 or ArcGIS, for example, or of course you can connect through an API. We are adding content every day and on over the world. Please notice that we will, of course, integrate our new constellation, PleiaNeo, 30 centimeter imagery, in OneAtlas as soon as the imagery is becoming available. Now, if we talk about layers, we can mention the base map, as I mentioned previously. It's a global layer where you have a worldwide coverage with spot at 1.5 meters worldwide, 50 centimeters in nearly 3,000 urban areas, so the biggest urban areas around the planet. And of course, the 30 centimeter resolution with PleiaNeo will be integrated into this base map. So we have more freshness, more accuracy, more precision. So we have a commitment to our customer where we are delivering a fresh base map with most of the years covered with images that are less than a year old. So it's fresh and accurate. One of the new assets we have integrated into OneAtlas, it's about the tasking. So our one tasking offer is now made available to our customers into OneAtlas. We are delivering our 4 modes. So the one day where you can select the acquisition, the day of acquisition for your imagery. So it can be today, or it can be tomorrow, it can be in 2 days, 3 days, 5 days. It's whenever you need. Well, now it's when you need an imagery as soon as possible. So that's something that it's going to be an urgent tasking for you. The one plan, it's you select a time frame. It can be between June 15th and August 15th, and we are going to collect one image within that time frame. And one series is for monitoring purposes, where you need a sequence of new acquisition on a certain area of interest, and you need several acquisition again during a specific time frame. So all of this is being made available into the web interface, or of course through APIs as well, so that can be integrated into any applications. So if we were talking about one tasking, and one tasking is integrating today Pleiad and Spot for the tasking. PleiaNeo will be made available during the last quarter of 2021, where you will be able to access archive, of course, but tasking as well. So tasking PleiaNeo 30 centimeters imagery is going to be a great addition in terms of assets to our constellation. We also have other assets with Vision 1, which is about 90 centimeters resolution. We are talking about the integration as well of our radar constellation, TerraSAR-X, Tandem-X, PAS. In the coming weeks, months, we will have the radar constellation into OneAtlas as well. So all of this imagery will be in one place, and you have guessed where into our OneAtlas platform. Of course, the future is being prepared. We are talking about CO 3D capabilities in the next years, as well as a new radar constellation. So plenty of new capabilities are coming into the Airbus constellation. Now, I would like to go for a focus on PleiaNeo. PleiaNeo is really our newest constellation. We are talking here about 4 satellites to be made available to the customers at 30 centimeters resolution, native resolution, where you're going to have access to a first-rate commercial GSD. You will be able to detect, identify, and recognize objects with the greatest level of details. Thanks to PleiaNeo, we will be able to improve algorithm precision. We will be able to have a regular access anyone's ears at least twice a day, and we can even increase that rate, of course, by going with Spot and Pleiades. So we will be able to acquire a lot of imagery, so 2 million square kilometers per day, thanks to our constellation of 4 satellites. And what is important here is that the access to this very high resolution imagery is open to all our customers, as it's 100% commercially available, and so anyone wishing to get access to the data can have it through One Atlas by contacting us directly, of course. PlayNeo is also about native location accuracy. So we are talking here about the highest performance in the geolocation accuracy with below than 5 meters. So 5 CE90 to be precise will be our minimum here. So that's something that we are going to deliver, of course, with PlayNeo. And you will be able to place your order, for example, for tasking up to 15 minutes before the plan is uploaded. So we will have multiple plan uploads during the day. Very reactive, 14 kilometers square, sorry. So great asset, allowing as well 6 multi-spectral bands. So we have introduced, of course, this PlayNeo capabilities in the past months, but now it's really live. The satellite has been launched end of April, and here I look what we observe today. For the first example we can talk about is Singapore and the Marina Bay Sands Hotel, for example. Here you can even see as the flower here, the Art Science Museum, and of course the large building are about the convention center in Singapore. The next example is about Roma. So we can see really the Castel Sant'Angelo here in the middle of the place. So the castle is really in the middle. We can see very clearly. So you can see really the sharpness of the details of the imagery here. We can even see on the right side of this castle as a Supreme Court of Italy. So it's really you can see all the details with the vehicles, the bridges. So it's really I would say pretty impressive imagery. Another example with Washington DC and the Capitol. The Capitol where you have the Senate and the House of Representatives, and you can see really very high detail, and you can almost see the Statue of Freedom at the top of the building here, and you can really easily recognize the memorial, the Grant Memorial on the left side of the building here. Another example on New York City, where you can really observe very significantly the size, of course, of the boats. We are here. We can see here the little island, which is on the right side of the image. You can see the distinctive size of the ships. I would say very big ships and very small ones. Here you can really see on the left part the Hudson River Park. You can distinguish the distinctive piers, so it's and you can see all the cars on the 11th Avenue on the in the middle of the image. So quite a lot of details where you can aim to trigger a lot of insights. And the last example I wanted to show about PlayNeo, it's about Dubai, where you have here the Ferris wheel, which is going to be the tallest on the Earth. We are talking about above 250 meters height. So it's really the largest one in the world on the Blue Waters Island here. So this is impressive. As you can see the cabin, you can see all the details. So really PlayNeo is bringing new capabilities into the commercial market. So maybe for today, we would like to invite you for a first poll.
So the first question that we'd like to ask, which Airbus imagery would be suitable for your application? So the poll should be launched. So Pléiade Neo 30 centimeters, Pléiade 50 centimeter, Spot 1.5 meter, or something else. We'll just give you a couple of seconds to log in your answer before we take a look. A little bit more time. And I believe that we can stop the poll now and take a look at the results. Just waiting for the results to show.
So I can see the result on my side. So you were 60% to explore the fact that you were looking for PNO in 30 centimeters. I believe that's really a great score and showing really your interest into this very new imagery, very high resolution imagery. Then for 30% of you was about Pleiades and Spot at 11% and only 2% for other. So thank you for this response. That's very interesting, and I believe we can move on with the rest of the presentation. So, but the rest of the presentation, I was mentioning all the data, the imagery side, and now I think it's worth mentioning our portfolio of analytics. So, of course, we have change detection capabilities, and you can see here a kind of a screenshot of what is being made available. So we are talking about changes on man-made changes, talking about roads, houses, buildings, earthworks happening, so automated detection of changes. We also can talk about activity analysis and monitoring, so about car detection, trucks, ships at sea detection, or aircraft. But today, we're going to concentrate on the high accuracy map extraction. So we talk about the 12 classes, land use, the building and road extraction, and also the 3D building. So Abigail will talk a little bit more about on that aspect. So Abigail, the floor is yours.
Thank you, Nicolas. All right, I'm just gonna get my screen up. So based on our attendee list, I see we have several guests who may be learning about Ecopia for the first time. So I'll start with a brief history of our company and the problem we endeavor to solve. Then we'll hop right into the data we're creating from Airbus's sub-1 meter imagery, the main ways Airbus's clients are using these layers, and lastly, how your team can leverage the Airbus and Ecopia partnership to improve your client satisfaction with their vector procurement process. As GIS professionals, we all recognize and understand the power and importance of location. Over the last 10 years, we've been fortunate to see tremendous growth in both the frequency and resolution of Earth observation data being captured, just like Airbus's Pleiades and Pleiades Neo constellations. These imagery providers are collecting millions of kilometers of pixels of our Earth on a daily basis, but so much of this data was going underutilized due to humans' inability to process it all in a timely manner. Geospatial data users were constantly having to make the trade-off between speed of data creation, quality, and price. You could use existing automation options to create vector data sets quickly and affordably, but the low quality of the data created by these tools would mean that your results and therefore analysis could be quite poor. Or all those time and cost savings you just achieved through automation would be lost through the need for weeks or months of manual quality assurance. Alternatively, you could use manual resources, whether those were in-house or offshore, and that would guarantee you that high quality, but you'd either be waiting really long times for the data to be created, or you'd have to pay a lot of money to achieve the short timelines. Due to the drawbacks of each of these options, it meant you were updating your data once every 3 to 5 years due to either time or budgetary constraints. And we all know that what a city looks like today will vary drastically in 6 months, let alone in 3 to 5 years. Ecopia's co-founders recognized this gap in the geospatial value chain and set out to use their deep knowledge in artificial intelligence, object detection, and GIS to bridge the gap. The result of this effort is Ecopia's proprietary semi-automated approach, which merges the output of its best-in-class neural network and a robust quality control process to enable our government, insurance provider, telecommunications company, and NGO clients to finally access vector layers that achieve GIS professional quality at countrywide scales that are easily updated at an affordable price. Over the last 8 years, we've continued to emphasize growth. Ecopia is always pushing the boundaries on how fast we can get data to our clients and expanding the level of detail we can extract from high-resolution imagery that our partners are capturing. For example, in 2016, Ecopia completed its first national dataset for the PSMA. In just 6 months, we mapped the entire country of Australia. That was 769 million kilometers of satellite imagery ingested by our neural network to deliver our client over 16 million buildings. Fast forward to 2018, only 2 years later, and Ecopia had created the most comprehensive building footprint layer of the United States, totaling over 169 million structures, in the exact same 6-month timeframe it took to map only 17 million buildings in Australia. That means we grew our output by almost 1,000% in under 2 years. And most recently, Ecopia created the first of its kind building, road centerline, and forest layer for all 51 countries in sub-Saharan Africa in under just 8 months. Over 24 million kilometers squared of sub-1 meter satellite imagery was ingested to produce over 416 million buildings, 17 million linear kilometers of road, and 582 million hectares of forest. To demonstrate the magnitude of the insights we were able to deliver the government and NGO clients, it's helpful to understand what existed beforehand. Prior to Ecopia creating their layer, government databases included just 2.5 million linear kilometers of road across the 51 countries. But as we stated, Ecopia identified over 17 million linear kilometers of road. That means 80% of roads in the region were unrepresented and unmapped. And so in addition to rapidly creating all these country and continent-wide projects, Ecopia also updates the datasets on an annual refresh cycle. Therefore, our clients are always working off of the most up-to-date dataset possible. I believe these 3 projects do a great job demonstrating that the short timelines we commit to our clients, we will always meet. Therefore, let's go a little bit further into the details of Ecopia's specification so that it's abundantly clear that when we say GIS professional quality, we mean it. As Nicola had mentioned earlier, Ecopia offers 3 core products from Airbus's Imagery: building footprints, road center lines, and a 12-feature land cover. All of these layers can be purchased individually or grouped together. And if you have a feature not listed here, but you'd like to see it automated, reach out to us directly and we can explore what we can do for you. So Ecopia has become renowned for their high precision building footprints. As you can see in this example, there are no slivers in the data. The lines are all perpendicular and not jagged, and there are no overlapping polygons, which is typical of other automated results. You'll also notice that Ecopia captures buildings where they actually meet the ground, not at the rooftop level. That is why it appears that there's a misalignment between the roofs and the building vector. Our goal is to provide you with vectors that precisely represent the real world. Therefore, we trained our neural network to account for the lean in imagery and to properly position the vector. This increased positional accuracy is critical for applications like emergency response planning, post-disaster assessments, logistics mapping, or even just general urban planning. Unlike most AI-based systems you've probably worked with, Ecopia's engine has been trained on a global scale. That means we're comfortable and have experience mapping on every continent in all the different environments. In particular, dense urban areas like the one shown here in India can easily be tackled by our engine. Our process extracts small-sized buildings with varying roof materials that sometimes fade into the background, as you can see in the imagery here, quite simply. I know we have a lot of participants on from Europe, so I made sure to include the famous row housing that exists in so many cities across the continent. We continue to hear firsthand how much time is saved for our clients by working with our layers that have the row housing split, as you can see here in Romania. For any kind of property-based analytics, this level of detail is invaluable. You're also seeing another example here of Ecopia extracting the building footprint, not the rooftop in these images. You can see the building vectors don't perfectly align with the imagery or the outlines of the roof. And that's again because Ecopia is positioning the polygons where they actually meet the ground instead of just where the roof is in the picture. As discussed, we're also delivering road vectors, and we can do that in either polygon or centerline format. So the pink here showcases our center lines. And as you can see, there are no undershoots or overshoots unless that's where the road is actually ending. And then our roads follow all standard topology rules. So you'll always have nodes at their intersections, as you're seeing here. Lastly, we can attribute all these layers with width, which is critical for any kind of logistics or transportation planning use case. Finally, we can also deliver full land use and land cover vectors on a citywide to countrywide scale. As I mentioned earlier, we have 12 core features, which we extract, as they tend to be the most widely requested. However, we can always customize these layers based on your use case. The standard features are listed here in the legend and include buildings, grass, tree, bare land, water bodies, and so on. When you receive our land use and land cover maps, you'll always be getting one contiguous layer, meaning there won't be any holes or any gaps in the data. So now that we've explored the core 3 features, it would be great to understand what layers our audience thinks would be most useful for the applications that they're using their GIS data for. So if you'd like to answer our poll on whether the land use, the building footprints, the road layers, or 3D data is most relevant to you, we'd love to hear it. It looks like our responses are all pretty close. We'll just give it a couple more seconds for everyone to answer and see if we can break these ties. All right, so it looks like building footprints are still the most sought after at 31%, but it looks like land use is trailing right after that, and buildings and 3D data. So it seems that all these layers are relevant, which makes me excited to discuss our next couple of slides. So while our base layers are embedded in hundreds of applications in both the commercial and public sectors globally, I think it would be most useful to focus on how governments are using the Ecopia land use and land cover data set to support their floodplain modeling and land administration policy. And that incorporates all those features we had just discussed. So due to the impacts of global warming, floods are becoming much more prevalent around the globe. An environmental agency assessment on the impacts of climate change in Europe found that floods and storms account for around 2/3 of the damage costs of natural disasters, and these costs continue to rise. The increase in damage costs is mainly due to land use change and increases in population, economic wealth, and human activities in hazard-prone areas. In order to minimize the impacts of these natural disasters and prevent them from occurring, several different forms of analysis must take place. Land use vectors form the base of all of this analysis. Typically, water authorities and taxation departments are looking to understand impervious and pervious surfaces in their jurisdiction. The reason being that impermeable surface can prevent water from draining, leading to increased risk of flooding. As cities have grown and become more urban, so have the number of paved surfaces. This results in less water absorption and more runoff, again, resulting in more flooding. While there are several innovative approaches to addressing the lack of pervious surfaces, what really matters is to successfully implementing any of these solutions is having a very strong foundational layer. Due to cost and time constraints, these land cover or impervious surface maps have historically been created from open low resolution data sources. While these layers were good enough, the level of detail achieved is far too coarse to accurately understand the natural and man-made environments. In addition to the lower quality, the fact that manual teams are creating these data sets makes it very challenging to accurately update. Natural features can be quite ambiguous in imagery, making it hard to classify them accurately. So when you add a human's natural subjectivity to the interpretation of a feature that's already ambiguous, you get layers that are inconsistent. This presents problems for doing base analysis, but it also makes updating the data complex, which leads to lots of falsely identified changes, making year-over-year analysis imprecise and therefore less impactful. In contrast, Airbus's high-resolution imagery, coupled with Ecopia's advanced neural networks, allows us to process land cover vectors that are incredibly granular and positionally accurate. And this is all done at the same price as creating those low-resolution data sets. This ensures that all your stormwater or water flow analysis you're undertaking is being done from the best information possible, increasing the success of the policies and strategies that the data is informing. Since all vector creation and updating is done by our AI, all features will consistently be captured the same way, delivering our clients with normalized results. This added consistency results in the ability to accurately measure the success of your policies and programs over time. As you can see in the images here, there's a stark difference between what was previously achievable and what can be done now and maintained at scale by Ecopia. So on the right side, you see Ecopia's data. On the left, you have the 30-meter land cover data set. And while you have a general idea of how the land use is being used, the degree of precision is incredibly low. Whereas in Ecopia's 1-meter layer, you're seeing clear boundaries around features and much more distinction between individual features. Obviously, Ecopia has extensive experience mapping the built environment, but even natural features are significantly more detailed, which is critical to understanding the state of your natural environment and then later tracking how it changes. Another powerful way these land use, land cover vector data sets have been leveraged by government departments is to improve their existing workflows in land administration. An informed and up-to-date land policy secures tenure for citizens, enables equitable land and property taxation, supports government functions, makes land dispute resolution fair and transparent, improves land planning, and can support poverty alleviation. From land surveys to using high-resolution aerial imagery and photogrammetric processing, the ability to obtain precise information with impressive levels of quality is nothing new. However, the ability to create and maintain high-quality vectors that meet the specifications of land administration authorities in just a couple of months at an affordable price, that was previously unheard of until Ecopia began their creation. Governments continue to move towards national spatial data infrastructure models. And the reason is that these data sets are so beneficial because they can serve a variety of departments, they're consistent across the full administration, and they lead to less duplication in efforts, which reduces costs and saves time. While existing vector extraction processes can create high-quality data sets, they're incredibly expensive and time-consuming. I'm sure you're noticing a theme here. To capture aerial imagery across a full country, it would typically take around a year to a year and a half. Then once you have this imagery, it can take an additional 3 years to digitize the whole data set. The reason being that manual teams are going to have to literally look at hundreds of thousands of kilometers of imagery to draw the layers. After all this work is done and your clients finally receive their property data, the information can be upwards of 4.5 years old. While this is still better than working off of data from 20 years ago, it's not an efficient and sustainable way to manage land information, especially due to the rapid changes so many environments are undergoing. Properties are going to be valued inaccurately, which can lead to government revenue loss or unfair taxation, which will undermine public trust and confidence in the full system. By working with Airbus and Ecopia, land information authorities demand for consistent, high-quality vector data, which can be rapidly generated and updated, as well as continued innovation on what information can be extracted from imagery at scale, is all being met. Airbus's constellation is capturing high-resolution 50 and 30 centimeter images of the Earth daily. By using Airbus's recent archive imagery or tasking a new capture, countrywide imagery datasets are easily obtained. Ecopia then takes this imagery and runs it through their vector creation process to deliver high-quality land cover vectors in under 3 months. Therefore, your analysis will be based on the built environment as of 3 to 6 months ago instead of 3 years ago. And the quality of the vectors delivered to you will still have that GIS professional quality. But building a robust data set isn't a one-time accomplishment. Routine updating is also critical. For this reason, Ecopia has automated the bundle adjustment, dense image matching, and triangulation components of the photogrammetric process. This allows us to align imagery and vector datasets from different time series, resulting in the ability to update in near real time. This also means that we can now deliver vector layers in the 3D environment, which only further enables the number of property details that can be extracted and the speed at which they can be captured. For example, if you want to track illegal constructions, Ecopia could identify when a new floor was added to a building. We're very excited to add this countrywide 3D capability to the suite of products you can purchase from Airbus and Ecopia. For a more detailed presentation on our 3D data, please reach out directly to your Airbus sales representative or to us at the Ecopia team. I'm going to let Nicola finish off our presentation by explaining the different ways you can access Airbus's and Ecopia's joint solution now.
Thank you, Abigail. Well, just as a reminder, you can always ask your question in the Q&A panel at any time. So I've seen we already have quite a few questions, so we'll answer that at the end with Abigail. So last part of the presentation about the access to these products. So first, how to really order. So it's easy. You just have to go to on One Atlas here, and you are selecting your AOI, so your area of interest. You select the product you need within the analytics toolbox. So here, the land use, the buildings, or the roads, and you submit a request to receive a quotation from our team. So it's pretty easy and straightforward. The other aspect is going to be about the custom projects. So it's easy. Again, it may be a little bit more complicated than going to, I would say, your topics may be a little bit more complicated than going just to the platform. So you want to reach out to us and explain your project. So that's not an issue at all. We have our team of experts ready to work with you on this project. So we have really turnkey solutions for you. We can deliver the work directly into your workspace into One Atlas, or you can directly ingest them into your own application or into any GIS. So of course, what we'll be delivering is really around the shapefile and the imagery that are needed. So based on that, we have mosaicing capabilities as well if you need very large territories. So that all those are fully feasible. In terms of delivery, so it's as well pretty, I would say pretty easy, since you just go again on One Atlas and you can really retrieve your vector product here, and the input image, it's available within your workspace. You can display those results as is being done and shown over here. So the vector product is really a GeoJSON format, so it can be downloaded. And for the custom, it's going to be, I would say, pretty much the same way where you are retrieving your products into the workspace. Other item we could talk about it's really the pricing. In terms of pricing, here is an example about, of course, the land use and the 12 classes. It's really, I would say, custom pricing, where user price is being part of, I would say, is price per building, per linear kilometer for the roads. It's really a combined price. So all of those items, it's based on the density of the land cover. So all of this is being, I would say, you make a request, we look at your AOI, and we definitely send you a quotation really quickly so you can validate and we can proceed with the order. So that the price is really, I would say, personalized and customized according to the area of interest. So maybe as a conclusion, we can see that you have some key benefits where it's reliable. So we ensure minimum of 95% accuracy on the product. It's really ready to use. It can be deployable on our Airbus Imagery, so Pleiades, Spot, and tomorrow Pleiades Neo. Fully scalable, as it can be done from a local scale and country scale, regional scale. Fully flexible on this, and flexibility as you can pay per order, so pay per project, or you can have a subscription where you consume whatever you want within your analytics subscription. So now I would say it's time for the question and answers. So maybe I'm going to start. I've seen quite some questions, and Abby, feel free to then take the hand on other questions. I'll start with with some questions from Diraj. Hi, Diraj, long time. So the question from Diraj is, when will the second Pléiades Neo be launched for larger area mapping projects? Well, second launch is planned on August 10th, so this summer. It's very close now. So the second satellite will be launched very, very soon. And maybe another question about David about what's the resolution of the dam. So if we're talking about wall dam, resolution is 12 meters as elevation and 24 meters for wall dam for auto-verification purposes. Maybe another question, maybe more for you, Abby. From Ole, what improvement of accuracy for building footprints products you expect to get from using Pléiades Neo images?
Yes.
Can you tell me more about the? Yeah.
No, thank you, Nicolas, and thank you, Ole. So what we will see, as Nicolas mentioned in his presentation, you're seeing that 5-meter positional accuracy now improved with the Pléiades Neo. So what you'll be getting is a much more positionally precise product. You'll also be getting, because there's higher resolution, there's more fidelity in the imagery, so you can see more specific details of the buildings. So you'll just get an even more precise building outline there from the data. And we're really excited to begin extracting off of that, because I think it's really going to expand the different applications for the data set together.
Thank you, Abby. So we had another question from Reza about change detection. And I was, is a change detection application based on optical or SAR? So it's based on optical imagery. So that's what I mentioned before, was based on optical imagery. So spell Pléiades and Pléiades Neo soon.
Great. And I think Jeff had a question just about the overall accuracies of the 12 class land use. What I'd recommend if you want to see our specification is just to reach out to us directly, and we can go into that in detail with you for all the features. But as we kind of mentioned in that last slide, we're hitting 95% accuracy, and that's something we guarantee. That's an omission and commission metric. You're also going to have 100% valid geometry. So we can speak more to that on the individual feature layer, but as a whole, 95% accuracy.
Okay, I think that's I'm looking for other answers. Other questions coming. So are Pléiades 50 centimeters optical images the only source for mapping building, land use, and roads? No, I would say that Pléiades Neo will be one for sure, but we can also use for some projects we have been using spot imagery. But Abigail, you may be talking a little bit more about this if you want.
No, we can definitely, we can be flexible. Again, it's all just going to depend on your application, how your client's using that data, and then their accuracy requirements. So we can be quite flexible in what we're using. And again, based on what your time requirements are and budgets. So again, I would just, with your specific requirements, one of our sales team members are always happy to help. I think this kind of ties into Brian's question about the rural areas and other features like the agriculture and forest classes. We have done work like that. So that's definitely something to reach out to us. We have some demo data sets we can show you. As long as the feature itself it has a very clear definition, it's distinct in the imagery, and it also can be distinguished from another feature class, it's probably going to be able to be automated. So just reach out to us directly for that, and we can discuss launching that with you.
Okay, I see maybe a question for you, Abigail. For the roads, are you able to identify and make a difference between gravel roads laterite roads or vehicle tracks?
Francois, if laterite roads are paved versus unpaved, that is something we've done before. I haven't heard of that, the laterite definition yet. So if you want, reach out to me afterwards to explain, but we can do paved versus unpaved. We haven't done a vehicle track versus different road types. So again, it'd be great if we could see what exactly you're looking for and then explore that with our technical team to see if they believe they can change the algorithm to be able to extract those features.
All right. Seems that there is an issue with my camera. Sorry about this, guys. So I have maybe there was a question: should we get a trial version? So of course we have sample products that can be delivered. So please contact us, and we'll be of course happy to deliver samples that you can observe on one atlas, for example. So definitely possible. And I have another question from Tarek. Does Pleiadian acquire Nadir and oblique imagery at the same time? Well, Pleiadian is very flexible. So of course it can acquire Nadir, and then it can go to very high angle if needed on such aspects. I don't know if what we are talking about at the same time. It's pretty flexible, so it can be done very quickly. But that's to be determined. What we are talking about here exactly. I'm looking at the questions coming and maybe other question for you. Do you see Abby on your side, Agal?
I think for right now, I think most of these questions have been, some theme of them have been answered. So I'd just say maybe reach out to us directly afterwards if you'd like to get more details on your question or you feel we didn't answer it fully.
All right. Then since we are all good, so if we have missed any question and if you need to contact us, obviously you feel free to reach out to maybe the email address will be showing here on the presentation, and do not hesitate to come back to us. Once again, you can connect to the Intelligent Airbus website, or to reach out to Ecopia, or even go to the oneatlas.airbus.com, where we will be, of course, proposing a free trial if needed on our data and analytics capabilities. So here you can see on the screen the two contact and email address where you can reach the Ecopia and the Airbus team. So on our side, we would like to thank you for your participation and all your interesting questions. We hope we have properly covered this topic today and answer to all your questions. And I wish you a great end of the day, and I hope to see you all soon.
Thank you all for your time today.